Hello everyone, in this video we'll be talking about data models and databases. We'll talk about data models, storage engines, graph database use cases, and we'll end this video with a brief illustration of how Neo4j is used for graph creation. To begin, let's talk about data models. Data models specify the interface for how users can store and retrieve data. There are two main types of data models, relational data models and non-relational data models. Relational data models are known to be table-based structure with a fixed and a predefined schema. This model is great for maintaining consistency and enforcing data reliability. Non-relational data models, on the other hand, often refer to them as non-SQL or not only SQL. These models support various forms of data structures and are more flexible compared to relational models. Most known non-relational data models are graph model, column model, key value model, and document model. Next, let's discuss storage engines, or as we know them, databases. We just talked about data models. We said they specify the interface for how users can store and retrieve data. Databases are the implementation of how data is stored and retrieved specifically on machines. Repeating, databases are the implementation of how data is stored and retrieved specifically on machines. There are two primary types, transactional databases and analytical databases. Transactional databases handle queries by row. They support indexation, which allows for more rapid extraction of data. Let's not forget, we have to be careful on which columns we are indexing. Transactional databases, on the other hand, adhere to ACID properties which ensure reliable transactions. ACID stands for atomicity, coherence, isolation, and durability. What about analytical databases? These type of databases handle queries by columns and support aggregation, which is essential for data analysis tasks. Before we move on, let's not forget what transactions are in the realm of databases. Transactions include actions like tweeting, watching a YouTube video, or uploading a file. Here we have some examples of NoSQL databases. We have Cosmos database, Apache Cassandra, Neo4j, Redis, Mongo database. Reddit, for example, they use the key value databases to store their users' credentials. As for Adobe, they use Mongo database to store documents. We have different databases for different tasks. Based on our requirements, we design our own databases. These requirements could be how we want to store our data, what information we want to be extracted, and if we want this database to adhere to ACID properties or not. Most of these databases we saw earlier are compliant to ACID properties. We talked about data models, we talked about databases, transactional and analytical. We mentioned the ACID properties. Now let's move on to graph databases. Graph databases are able to implement both transactional and analytical processing. A graph database is represented by nodes and edges. Nodes are these circles as we see in the picture. They represent entities. Edges are the relationships between them. This structure is particularly useful for applications involving complex relationships like social networks or recommendation systems. We have two types of graph architectures. We have directed graph and undirected graph. Directed graphs are graphs with one direction. We have edges with one direction indicating a one-way relationship. On the other hand, bidirectional graphs, we have edges that imply a two-way relationships. To understand more, let's give an example. Twitter designed their feature follows as an unidirectional architecture. If user A follows user B, vice versa does not have to be the case. However, Facebook implements a bidirectional architecture for the friendship property. If user A is a friend with user B is also a friend of user A. Understanding these differences between these architectures helps in designing databases that best fit the needs of specific applications. There are many different applications of graphs. They are used to design social graphs, infrastructure graphs, brain graphs, web graphs, molecular graphs, gene graphs. Even big companies like Apple, Alibaba, Amazon are integrating them with AI to gain specific insights and to build knowledge graphs. Before we showcase a brief demonstration, I want to mention the term big data. Most of the time, big data refers to the massive amount of data. We saw earlier different ways to interrogate data. We can interrogate it using rows, using columns, aggregation, indexing, using graphs. But in the realm of the big data, large amount of data is not the only obstacle, but how to process this data, how to extract insights from it, how to manage it. To answer these problematics, technologies like Hadoop and Spark were developed to process big data efficiently using batch processing and other techniques. Now I leave you with my friend Fatima Zara for the demonstration.
Hi, I am Fatem Zara Hakimi. I'm going to talk about developing a knowledge graph for a research institution using Neo4j. The projects involve creating a knowledge graph for a research institution to centralize and organize information about researches, publication, projects, and their relationships. A notch graph enables the presentation and exploitation of interconnected data in intuitive manner, facilitating search, knowledge discovery and analysis of relationship between various elements of the institution. Our objective is first we want to centralize information about researches, publication, projects, and collaboration. Second, we want to facilitate the search and discovery of relevant information. Third, we want to analyze the relationship between different entities to identify collaboration and immigrant research areas. To do this, we follow this step: installation and configuration of new 4G, data modeling, identifying entities, research projects, publication, and institution, and define the relationships between these entities, like works on, collaborates with, etc. Database creation: we create nodes for each entity and establish relationship between these nodes using Cipher. And the here is an this is fictional dataset for the knowledge graph project for a research institution. Their data include researches, publication, projects, and collaboration, and the relationships between publication and projects, between collaboration and researches. After importing the data, we using cipher requests to explore the knowledge graph and gain insights. Insights, here, for example, here is find all researchers working on the AI, working here, working in the AI researches projects, and also find the collaboration between researchers, and also we can find the list of publication by research. This project provides a practical understanding of creating managing managing a knowledge graph with Neo4j, as well as leveraging relationships between entities to generate valuable insights. So thank you for watching and thank you for listening. See you next time on next projects.